So I will give you a quick rundown of our application. So since we are analyzing the weather impact on the grid lines, we have created grid static input variables where we will give weather data. So we try to implement real-time data through APIs, but the challenge was the data was not that varied in nature. So that's why we were not able to demonstrate all the scenarios here. So we created three scenarios: worst case, typical day, which is normal case, and the best case, where the temperature is low as well as the load is not high. So let's go with the worst case. So if I change to worst case, then you can see the 14 lines are in critical, 15 lines are in warning, and 48 lines are normal. So if I want to see the which lines are getting affected and which lines are in critical condition, and I will just zoom into this GIS map where the lines are getting color coded as per the status. So let's say if I click on the red line, you can see the details, line ID and the parameters of that line. So similarly, if I want to take a deeper look into what's going on behind the scenes, I will come to table view, and here you can see the detailed calculations, like how we are calculating dynamic rating using the IEEE standard, as well as what's the current load and what's the utilization. So we are also doing additional analysis here where we are comparing the static rating with the dynamic rating and how it's changing based on the weather, and you can basically filter out the lines using the different statuses, and you can see the detailed analysis also here. So if you click on view details, you can see a 24-hour load forecast, which is done by a fixed formula, which is derived from the time of the day, utilization, as well as the weather forecast. So moving on to time lapse analysis, like this is the one feature that we spent most time. And this is like the most innovative feature that we have implemented. So this is where we try to give a overview of the lines based on the changes, based on the time in the day. So we will set the weather parameters and we will basically hit on play, and the calculations will be done based on the time of the day, and the loads will update based on that. So you can see the lines are getting updated to a different utilization, as well as the colors are changed. So using this, the analyst can get a overview of how the loads change throughout the day for the given weather. And the second one was the N1 analysis. So this is like a failure analysis where we try to simulate a failure of one line. So whenever the line fails, we redirect the power to another lines that are connected to that line. So you can select which line is failed. So I will go ahead and select, let's say, line 62. So here it will show the power that was going through that line. So that was 7.71 megawatt, and the connections it had was bus 24 to bus 36, and the affected lines, those are the connected lines that got affected. So those are three, but none of those lines are in any warning situations, since even though we are redirecting the power from that failed line to these lines, the lines are still holding well below their maximum utilization. So then hence they are in normal statuses, but if I select any other line, it will basically go through uh, other statuses like critical or um, warning situations. So yeah, that's our implementation.